Let's look at this series of numbers. Every number is larger by 2 from the previous number. If the first term is a1, the second term is a2, and the nth term is an, then an is an minus 1 plus 2. In this series of numbers, every number is smaller by 3 from the previous number. So an is an minus 1 minus 3. This kind of series is called arithmetic progression, or AP. In an AP, the difference of two adjacent terms remains constant. D is the common difference. An is an minus 1 plus d. In the first AP, d is 2. In the second AP, d is minus 3. A is the first term. A2 is a plus d. A3 is a2 plus d. A2 is a plus d. So A3 is a plus 2d. A4 is a3 plus d, which is a plus 2d plus d. So it is a plus 3d. In general, an is a plus n minus 1d. Now let's see how to find the sum of the first 10 terms of an AP. We use s to denote it. It is a plus a2 plus a3 plus all the way to an. It is also an plus an minus 1 plus an minus 2 plus all the way to a. If we add from a to an, it is a plus d, plus a plus 2d, plus all the way to a plus n minus 1d. If we add from an to a, we know an minus 1 is an minus d. An minus 2 is an minus 2d. So s is an, plus an minus d, plus an minus 2d, plus all the way to an minus n minus 1d. Let's add these two together. It is 2s. The first two add to a plus an. The second two also add to a plus an, because plus d and minus d get cancelled. So are the third two, and all the way to the nth terms. So altogether there are n times a plus an. Therefore, s is half n times a plus an. An is a plus n minus 1d. Put it in the formula, we get the second formula for s. It is an plus half n times n minus 1d. You can use either one of the formula to calculate the sum, depending on the parameters known to you. For example, calculate 1 plus 3 plus 5 plus 7 to plus 57. This is the sum of an AP. The first term a is 1. The common difference d is 2. Now let's find out the number of terms n. We know an is a plus n minus 1d, which is 1 plus n minus 1 times 2. An is 57. So n is 29. Using the first formula, we get s as 29 times 1 plus 57 over 2, which is 841. Let's look at some examples. The fifth term of an AP is 21 and the sum of the first 6 terms is 90. Find the 15th term. We need to use the proper formula to find a and d. A5 is a plus 4d, and it is 21. The sum of the first 6 terms s is 6a plus 6 times 5d over 2, and it is 90. So we need to solve these two simultaneous equations to get a and d. Multiply the first equation by 6 and we get 6a plus 24d is 126. Subtract the second equation from it, we get 9d is 36. So d is 4. Put it back into the first equation, we get a as 5. So a15 is a plus 14d. This is 5 plus 14 times 4, which is 61. The sum of the first 10 terms of an AP is n squared plus 3n. Find the nth term. We know the sum of the first 10 minus 1 terms plus the nth term is the sum of the first 10 terms. So Sn is Sn minus 1 plus an. Sn is n squared plus 3n. Sn minus 1 is n minus 1 squared plus 3 times n minus 1. This is n squared minus 2n plus 1 plus 3n minus 3. Therefore, an is n squared plus 3n minus n squared plus 2n minus 1 minus 3n plus 3. It is 2n plus 2. In this class, we learned In AP, A is the first term and D is the common difference. AN is AN minus 1 plus D. AN is A plus N minus 1 D. The sum S is half N times A plus AN. It is also AN plus half NN minus 1 times D.